Have you ever looked at a giant skyscraper and just wondered, how in the world does someone build that from a flat piece of paper? Well, today, we're going to decode the simple but honestly brilliant language that makes it all possible.
I mean, that's the real challenge, isn't it? We live in this big, three-dimensional world, but pretty much all our plans get communicated on flat surfaces, paper or a computer screen. So how do you bridge that gap without losing all the important info?
Okay, let's make this super real. Picture this. You're building a custom skateboard ramp. You've got one awesome-looking photo to work from. Seems straightforward enough, right? What could possibly go wrong?
Oh, a lot. A whole lot can go wrong. See, from that one angle, the slope looks perfect, but you have zero idea how deep it is or how wide. You don't know where the supports, the most important part, are supposed to go. A single picture isn't just missing a little info, it's dangerously incomplete.
And that's exactly why the pros don't mess around with single pictures. They use this incredibly powerful universal system. It's kind of like a secret language for building things right every single time. And that system has a name. It's called a working drawing. This is the official plan. So instead of one confusing 3D picture, it uses a set of totally flat 2D views that, when you put them all together, tell the entire story with zero confusion.
And the real heart of this whole thing comes down to three specific points of view. You've got the top view, like you're a bird looking straight down, the front view, looking at it head-on, and the side view, from either the left or the right. That's it. 3 flat drawings. That's the magic number.
So the big question is, how do these 3 kind of boring flat pictures create a perfect 3D image in your head? Well, this is where it gets really, really clever. Let's break down the logic behind it.
Okay, here is the secret sauce. Each 2D view can only show you 2 dimensions, which means it has to hide the third one. So the top view, it shows you length and width, but the height is totally invisible. The front view shows you length and height, but now the depth is gone. And the side view, well, it shows width and height, but it completely hides the length. Each one gives you just a piece of the puzzle.
To really see how this works, let's just use a plain old brick. We'll give it some simple dimensions to make it easy. Let's say it's 20 centimeters long, 9 centimeters wide, and 6 centimeters tall.
All right, so if we look straight down from above our brick, what do we see? Just a simple rectangle. And its measurements are the brick's length and its width. So we see a 20 by 9 centimeter rectangle. From this view alone, we have no clue how tall that brick is.
Now let's move around to the front. From this angle, you see a totally different rectangle. This one is made up of the length and the height. It's 20 by 6 centimeters. Now we finally know the height. But guess what? The width is now completely hidden from us.
And last but not least, the side view. This one shows us the width and the height, a 9 by 6 centimeter rectangle. By itself, it's just as incomplete as the others. But when you put these 3 views together, suddenly you have every single dimension you need. No more guesswork.
So if there's one thing to remember, it's this. Each view on its own kind of flattens the object. It collapses one of the dimensions. And that's a limitation, for sure. But when you use all 3 views together, those limitations totally cancel each other out. And just like that, all the doubt, all the ambiguity is gone. Okay, so now that we know how to break a 3D object down into its 2D views, let's flip it. Let's try going the other way and see how you can use a blueprint to build that 3D object back up in your mind.
All right, it's time for a little pop quiz. I'm going to give you the 3 views of a mystery box. Just using these clues, do you think you can figure out its exact length, width, and height? Let's find out.
Okay, here are your clues. The top view is an 8 by 6 centimeter rectangle. The front view is 8 by 5, and the side view is 6 by 5. All the info you need is right there. So, how do we crack this code?
There's actually a really simple, logical trick to this. Just think back to what each view shows you. The number that shows up in both the top and the front views, well, that has to be the length. The number that's shared by the top and the side views, that's your width, which means the one shared by the front and the side views, that's got to be the height.
So let's solve it together. The number shared between top and front is 8, so the length is 8 centimeters. Between top and side, the shared number is 6, so the width is 6 centimeters. And finally, between front and side, it's 5, which gives us a height of 5 centimeters. And just like that, you did it. You just read a blueprint.
Now this isn't just some neat little brain teaser.
This skill is, and I mean this, absolutely fundamental to how our modern world gets built, from giant buildings to the phone that's probably in your hand right now.
Think about architecture. The top view, that's the floor plan. It shows you the layout of all the rooms. The front view sets the wall height, where the doors and windows go. And the side view defines the slope of the roof. You absolutely need all three to build a house that won't fall down.
Or look at something like a game console. The front view is designed for the gamer, showing where all the buttons and joysticks go. The side view defines its thickness, how it feels in your hands. And the top view? That might detail where all the ports are. Every single detail is planned out using these views.
And in engineering, my gosh, it is non-negotiable. For a sports car, that iconic, sleek profile comes from the side view. The front view defines its aggressive, wide stance, and the top view shapes the hood and the roofline. It's all specified with complete precision before a single piece of metal is ever touched.
And it all comes back to this one simple, powerful number. Just three. Three simple, flat drawings that, when you put them together, give us the power to build pretty much anything we can dream up with total confidence.
So the next time you see a building going up, or you pick up a new piece of tech, or even just look at a chair, pause for a second. Try to picture its three views. Now that you know this secret language, I wonder, how will you start to see the world differently?